All right, finishing strong, unit 10 and 11. Not that many questions left. Oh, great questions. These questions about polar curves. We have our understanding of polar curves being graphed differently than rectangular curves. It's about a radius placed on an angle. So what we like to do is graph the rectangular form and understand what that means if you're talking about radiuses at angles. We got 2. We're going to go up to 6. We're going to go down to -2. We got cosine, so we're going to start at the bottom. Bang, boom, bang, bang. We got pi over 2, pi, 3 pi over 2. There's no period adjustment. Now, here's the key. We got to figure out when the radius is 0. When the radius is 0, our polar graphs are at the origin. I spent a lot of time doing this. A lot of you did a very good job on this. Now, when does 2 minus 4 cosine theta equal 0? We talked about this in class. It's like, what are the values that are nice outputs for cosine? Half. What are the angles when cosine's a half? The angles when cosine's a half are the pi over 3s, where the adjacent is a half. Look, unit circle just showed up. Finally, something other than a 45, 45, 90. So this angle is actually pi over 3. This is 2 pi over 3. This is going to be 4 pi over 3. This is going to be 5 pi over 3. Wait, never mind. This is pi over 3. We want positive a half. Whatever. Pi over 3. You don't want all of them. We want cosine theta to be positive a half, so that we do 2 minus 2. So cosine's positive in the first and the fourth quadrant, so we want pi over 3, that one, and then we want 5 pi over 3, this one. Boom. This would help us potentially sketch the curve if we wanted to. We don't want to. Rather, we are going to be looking at pi to 5 pi over 3. Now here's what's going on. Our radiuses are positive and decreasing from pi to 5 pi over 3. Our radiuses, if they are positive and decreasing, are getting closer to 0. Our radius is decreasing, the distance, not decreasing, our radiuses are getting closer to 0. My distance is decreasing. Wrong. From 5 pi over 3 to 2 pi. From here to here. My radiuses are negative and decreasing. Because my radiuses are negative and decreasing, they are getting further away from 0. Because my radiuses are getting further away from 0, the distance is increasing. The distance is increasing because f is negative and what? Nope. It's negative and decreasing. Wrong. Pi to 5 pi over 3 again. Positive and decreasing. Distance is decreasing. Cha-ching. This would have been correct if it was distance is increasing. It's not. Distance is negative and decreasing. It is therefore getting further away from 0. Therefore, distance is increasing. Don't you love this question? Portion of the graph from pi over 2 to pi is in quadrant 4 from D to E. So this is like, I already know what the answer is. If we're going from pi over 2 to pi, and we're starting for a portion of the graph d to e, I can kind of tell that d to e exists opposite of the angles pi over 2 to 3 pi over 4. You can see these are negative radiuses from pi over 2 to 3 pi over 4. They're existing right there. Which means from 3 pi over 4 to pi, I'm probably not bouncing off things. I'm probably going to continue on through here and go e to a with my positive radiuses. That is my portion. It's going to be d to a through e. You can kind of just see that. You just think about where are your angles, where's your graph? Positive radiuses, negative radiuses. They're telling you you're starting with negative radiuses. So I think it's quadrant 2, e to a. Let's just double check. 6 cosine 2 theta. Rectangular. 6 cos 2x. Rectangular. 0, 6, negative 6. Adjust my period. Divide by 4. Exactly what we expected. Cosine. It's exactly what we're expecting. Between pi over 2 and 3 pi over 4, our radiuses are negative. Between pi over 2 and 3 pi over 4, my radiuses will be in the opposite quadrant between 3 pi over 2 and 7 pi over 4. Here are my opposite radiuses getting plotted in this direction as my angles are going in this direction. Angles are going here, opposite radiuses go here. Then from 3 pi over 4 to pi, we have these positive radiuses starting at 0 going to 6. Well, from 3 pi over 4 to pi, we can see we are starting with a radius of 0 and we are increasing out to a radius of 6, our maximum. You know what's the easiest way to do this problem, which we didn't really tell you when you're doing your homeworks, is actually just plug in certain values. Like pi over 2 and 3 pi over 2 are my big ones. If I plug in pi over 2, I need to get one of these two values. If I plug in 3 pi over 2, I better get one of those two values. It's either going to be negative 2, positive 2, negative 4, or positive 4. So I'm just going to realize really quickly, it's not the cosines. It's not the cosines. So it's one of the two signs. I mean, if I plug in pi over 2 or 3 pi over 2, I get 0 for the cosines. If I plug in pi over 2 into this guy, I get 6. If I plotted this guy, it should have a radius of 6 at pi over 2. I don't see that. Let's double check. I mean, that's not the guy. If I plugged in pi over 2 into this guy, sine of pi over 2 is 1, 4 plus 2 is 6. But if I plug in pi over 2 into this guy, I can see 2 minus 4, which is negative 2. And I got that negative 2 point right there. If I plug in 3 pi over 2 into this guy, it'd be 2 minus negative 4, because the sine of 3 pi over 2 is negative 1. And that's where I get that positive 6. So, man, it's a lot easier than trying to sketch them all, right? You could double check by sketching maybe B's midline, amplitude. There you go. Sine, negative. This will be at pi. This is pi over 2. I can see at pi over 2, I have negative 2. Bam. You can see you have 0. You can see you have 2. When does sine equal a half? When will this equal 0? Is that the pi over 6s? Five pi over 6. That'll be the zeros. 0 pi over 6, positive radiuses starting at 2, getting closer to 0. Pi over 6 to pi over 2. We have negative radiuses that are increasing until they get to negative 2. This is how the graph is sketched. Pi over 2 to 5 pi over 6. Negative radiuses that are decreasing, they're getting closer to 0. And then 5 pi over 6 to 3 pi over 2. Positive radiuses that are increasing till the maximum. And then we finish off going back to 2. We didn't really talk about this, but it's important. Geometric series sequences are exponential. Arithmetic sequences are linear. So it's like the first term is 3, the fourth term is 24. You have like two equations you could set up. This is very similar to the free response question where it's like 24 equals a b to the fourth. 3 equals a b to the first. And you could like honestly plot the data points if you wanted to and find the exponential guy. Or there's some common ratio times r times r times r. This is like if you divided these two equations, you would get 24 divided by 3, which is 8, equals b cubed. So it's like 3 times r cubed equals 24. Oh yeah, okay. Like r cubed equals 8. So the cubed root of 8 is 2. So your ratio is times 2. So this is 6. This is 12. You know, it's like, it's exponential, which is why we didn't include it. And we weren't worried about you figuring it out. Geometrics are exponential. Solve them just like exponential functions. So it's exponential times 3 times 3 times 3 times 3. Classic. Teacher making a problem and making a mistake, forgetting to write over things. Makes you second guess yourself. That's it. 84 problems. We got to start on the calculator part, which you're going to see very quickly at the calculator part. So you don't use your calculator that much. A lot of them are just like the calculator doesn't help you at all. You really have to know your stuff, or you have to use your calculator. These questions here, you could have turned your calculator into polar mode and graphed all 4 of them. That's cheating. that means you don't really know what you're doing. So it's like these questions here, if you had a calculator, be a significant advantage. You will not see these types of questions on the calculator part. When you get to the calculator part, you're going to see it's either questions where the calculator won't help you at all or you have to use it. Okay, later.